Hello everybody and welcome to today's lesson on recursive sequences. Today our objective is we will define a sequence recursively and we will find terms of a recursive sequence. Well then, what is a recursive sequence? A recursive sequence is a sequence that uses previous terms to find the next term. So we cannot write the rule without using the term that we previously found again and again. And the best way to understand this is looking at examples. And here we have two examples and we're supposed to write the first 5 terms of the following recursively defined sequences. And in order to do that, you have to have a first term, right? And it's given here a sub 1 is 1. And the rule that we have to use is a sub n is equal to 4 times a sub n minus 1. Or what that means is 4 times the previous term. So a sub 2 will be equal to 4 times a sub 1. And that is 4 times 1. Or just simply 4. A sub 3 then will be 4 times a sub 2, and that is 4 times 4, and that's 16. So we're using the 4, that's the previous term, to find our next term, a sub 3. And then a sub 4 will be 4 times a sub 3, that means 4 times 16. And that is 64. So the 16 now goes in to find our next term. And then a sub 5 will be 4 times a sub 4, and that is 4 times 64, which is 256. And again, the 64 is the term we needed to put in here to find our next term, in this case a sub 5. In our next example, we have our a sub 1 and we have our rule, and the rule also has a changing element in there in terms of the n. So a sub 1 is equal to 1. Now a sub 2 is equal to n times, which is 2, a sub 1. And that is 2 times 1, and that's 2. A sub 3 will be 3 times a sub 2, and that is 3 times 2, which is 6. A sub 4 will be 4 times a sub 3, and a sub 3 was 6, so 4 times 6 is 24. A sub 5 is 5 times a sub 4. 5 times 24 is 120. And again, you see how each time the previous term went into the formula to find the next term. So for both of these examples, you can see that very well. And that means we have to find every term to get the next term. Let's see how we can use this in a real-world application. A pond currently has 2,000 trout in it. A fish hatchery decides to add an additional 20 trouts each month. In addition, it is known that the trout population is growing at a rate of 3% per month. Write a recursive sequence to model the trout population, and what is the trout population after 4 months? Now, I don't know how they were able to figure out that they had 2,000 trout in that pond, who went ahead and counted it. But anyway, that is the number that we are given. A sub 1 is 2,000. And now we need to establish our rule. A sub n is equal to 1 plus 0.03 times a sub n minus 1. And that is the part that takes care of our monthly growth at 3%. And then we also add a fixed number of 20 each month. That's how we get a sub n. And we need to start with a sub 1 to find each subsequent term. And now we need to find the population after 4 months. So we need to find a sub 2, a sub 3, and a sub 4. A sub 2 is 1 plus 0.03, a sub 1 plus 20, which is 1.03 times 2000 plus 20, or in other words, 2080. Then a sub 3 is 1 plus 0.03, a sub 2 plus 20, which is 1.03 times 2080 plus 20, and that turns out to be 2162.4 trout. So we have 0.4 trout swimming around there somewhere. I don't know if you've ever seen a 0.4 trout. I haven't. Let's not worry about that. We're going to use the decimal and then round at the end. And in month 4, a sub 4 is equal to 1 plus 0.03, a sub 3 plus 20, and that is 1.03 times 2162.4 plus 20, and that would be, and now let's go ahead and round it, approximately 2,247 trout. So after 4 months, the trout population is 2,247. And on we go to our next example. Robert owes $2,000 to a credit card company that charges an interest rate of 5.4% per month. At the end of each month, he makes a payment of $100. Write a recursive formula for the balance at the beginning of each month. So we have our a sub 1. A sub 1 is equal to 2,000. And similarly to the previous example, we have an element where our starting balance grows by a certain percentage, and then something happens with a fixed amount afterwards. So a sub n is 1 plus 0.054 times a sub n minus 1, and then we in this case actually subtract 100 from that amount. So let's see what that gives us in month 2. A sub 2 is equal to 1.054 times 2000 minus 100. And as you plug this into the calculator, you will find out that the amount is 2008. So that means at the beginning of month 2, Robert owes $2,008. All right, that was easy enough in terms of the math, but let's think about this for a minute. Robert paid $100, and still he actually now owes more than he did before. That's not so great. So he paid part of the interest with his $100, but not even all of it, and the amount that he owes went up rather than going down. Well, I think Robert needs to think about his strategy here, or he's going to be in big trouble. All right then, just a thought. And now go ahead and watch the second part of this tutorial, where we'll have another example and talk about a very famous recursive sequence.